Hi, I'm Brian from Reason Test Prep. This is another video in our series on the key to a high GMAT or a GRE score. If you haven't already watched the first video in this series, it'd be a good idea to go and watch that. We have a lot of important tips that I think will kind of frame a lot of what I'm about to say in this video. But I wanted to give some more examples of how you can, apply quantitative and verbal reasoning to GMAT and GRE questions. And that is the secret. That is the key to a high GMAT and GRE score, is understanding that the GMAT and the GRE are tests of quantitative and verbal reasoning. So yes, content mastery is important, but quantitative and verbal reasoning are more important, and you can't achieve a top score without them. So that's really the thing that people most misunderstand about these tests, is they study a lot of rules and formulas and things like that, and they don't understand that, yes, that's important. You should, you need to know on the GRE, you need to know your geometry rules, and on both tests, you need to know your exponent rules and, formulas and things like that. That's important, but that's not enough. The tests kind of expect you to know that stuff, but then they're really testing how you can take that knowledge and apply really good quantitative and verbal reasoning. So that's really the secret. And so, a lot of what we're doing at Reason Test Prep is really helping people to understand that and helping them understand how to approach questions with that in mind. And that's something you could do in your studies, is really try to sort of manifest that understanding and that approach. So anyway, we have a question here, and this happens to be a GMAT question. It could be a GRE question as well. It totally could be. It's just that it's quite a hard question. So perhaps at the limit of what you might see on the GRE in terms of difficulty. And, the first thing I want to say is that, how you choose to approach questions is itself an exercise in reasoning, right? So in other words, most people, they look at the question, at any question, and they just immediately kind of just dive right in. And often they think that there's one right way or only one way to do the question, and that's what they're being tested on is, did I study this, know how to do this? No, that's not what either test is about. It's really about your ability to figure out how to approach the question effectively. That's why these are called problem-solving questions. You're solving problems. Most people look at this question and they immediately think algebra and immediately start writing out the equation and trying to, sort of solve for x, because that's what the question is obviously asking for here, right? But that's not the only way to do it. And the question you need to ask yourself is that the best way for you to do this question, right? And the truth is, this algebra is very, very hard. So, unless you look at it and you have a good idea of what you're going to do, there's a good chance you're going to just start moving things around and not get anywhere with it, okay? So, well, what else could you do? The first thing is you could just guess and move on, right? That might not be a bad idea if you're not sure that you're going to actually be able to solve this. The other thing is, another major strategy or just understanding that we try to instill in people is that doing things in a more tangible or concrete way is often easier than doing them in a more abstract or conceptual way. So, here doing the algebra and using variables, like that's by definition abstract and it's difficult. And so, okay, what could you do? Well, you could just start, sort of plugging in numbers for x. Now, that might seem crazy. And if you look at the answer choices, clearly the value of x is not even an integer, right? But, if you just didn't even know where to start, you could be like, well, let me think about this. What if I made, x 5, right? If you put in a 5, the first thing you'll notice is that this side will be negative. But then, how is that going to equal this, which is definitely going to be positive, right? And in fact, this right side of the equation is always going to be positive because, that's about 3, a little bit bigger than 3. And then square root of something is always going to be positive or 0. So certainly you can already see that x couldn't even be 10. That would get you to 0. It's got to be bigger than 10. However, even if you didn't, I just wanted to demonstrate how by just plugging in numbers, things start to happen. You start to get to a kind of a deeper understanding of what's happening, and that's often the case. But even if you didn't think to do that, you could certainly look at the answers and be like, look, one of these is the value of x, right? Now, it would be hard and time-consuming, I think, to plug these in as is in here and here, right? You could do that, but that looks pretty messy. So what else could you do? Well, you could estimate and be like, well, I mean, I can say roughly that equals, again, square root of 9 is 3, so square root of 10 is a little bit bigger than 3. So, that's call that, about 4 point something, right? Again, if you just started there and plugged that in, you'll realize that can't possibly work because, again, we said it's got to be bigger, x has to be bigger than 10. So right away, boom, that's out. And already you're starting to narrow down answers here in a way that most people who try to do this algebraically would not be able to do. So anyway, if we just keep going, I mean, this is going to be, I wouldn't even necessarily go in order. But you can see the answer choices go, from smallest to largest, and that's almost always the case on both GRE and GMAT. So, we certainly don't have to try each one. But yeah, I mean, this is, about a little bit bigger than 13. This is going to be about 14. This is 10 plus 2 times a little bigger than 3. So, 16 point something, 16.2 or something. And, this is going to be 11 plus, call it 3.1 times 2, so 6.2. So the whole thing would be about 17.2. Again, you really could just be like, all right, I'll jump here and try C and see what happens. But anyway, let's do that. If we started at C, and again, we could have even not looked at those and just come here to choice C, you will realize if you plug that in, so, roughly 14. So you're going to have a 14 here minus 10 is 4. And then you're going to have square root of 14, right, plus square root of 10. Now, square root of 16 is 4. So square root of 14 is almost 4, and this is a little bigger than 3. So the right side of the equation here is going to be about 7, right? And this is only 4. So again, we clearly need a bigger value of x, right? So already we could say this is out, and it seems like b would also be out, right? Let me actually just get rid of these things here first. So these are probably out. And then if you try, let's say choice D, right, 16.2, or, about 16. So you minus 16 or minus 10 from that, you're going to get about 6. And square root of 16 is 4. But again, 4 plus about 3 is 7, and this is only 6. And notice what's happening here. And again, this is what happens when you start putting, numbers in and getting tangible. You start to notice things. Notice that when we had square root of 14, it's almost 4, and square root of 16 is 4. So like this quantity is not really changing very much. If you put in 14, or 15 or 16 or 17, like it's going to be about 4 no matter what. So essentially, given these answer choices here, like this is about 7, right? And so, yeah, I mean, D is too low once again. So E, if we plug in 17.2, right? 17 or 17-ish minus 10 is about 7, and then square root of 17 is, a little bigger than 4 plus 3 is basically 7, a little bigger than 7. So yeah, I mean, the answer really has to be E. It's not even a guess. I mean, it definitely needs to be E. D is definitely too low. So it's taken me kind of a long time to explain that, but everything I just did there, that could all happen in a minute and a half, 2 minutes, right? And this is a very, very hard question because the algebra is very, very difficult. So most people are just going to get this question wrong. They'll probably waste a lot of time on it. And, this is a question you can get right just by, like I said, being a little bit more tangible and, applying some quantitative reasoning, right? Like the number plugging there and thinking about what's happening. Oh, this side's too small. This side's bigger. I think I need a bigger value of x. Like that's the kind of quantitative reasoning that the both tests reward. So anyway, okay, what to do with this? Well, again, in the first video in the series, we had a larger set of tips. I don't want to repeat everything that we said at the end of that video, but, it might be helpful to go back to that first, if you haven't already, go back to that first video and see towards the end, we talk about some ways that you can apply this. But really the main, I'll just kind of repeat something that we said there. The main thing is that you always want to have the right mentality, which is that you need to align yourself with what the GMAT and the GRE are meant to measure and reward in the first place, and that is reasoning, quantitative and verbal reasoning. So, you really want to kind of lean into, as you're doing the practice questions and, trying to prepare for the test, you really want to lean into reasoning and problem solving and kind of lean away from the just pure application of content that you have memorized, right? Like that's not what it's about. So again, in the context of this question, people will be like, oh, I didn't study enough algebra. Honestly, no amount of studying of algebra is going to get most people to the right answer on this question. So it's really, except for the most exceptional, people in math, we're talking about people who are going to get a perfect score or near perfect score on the quant section of these tests. Apart from those people, really the way to attack this question is to be a good problem solver and to apply, good quantitative reasoning. So, try to really lean into that as you're doing practice questions. Even when you get them right, it's good to, be like, could I have done this better? Could I have applied more reasoning and less just kind of applying a formula, especially if you ended up taking a long time or obviously if you got the question wrong. Okay, anyway, I hope you found this video helpful. If so, please feel free to subscribe. And if you know of anyone else who you think might find it helpful, please feel free to share it with them. Thanks for watching.